a minute or two has passed.
Can everybody just mute their microphones if you don't mind, please?
All right. Good afternoon to everybody again. Welcome to this CONCRETEfix series 5, number 3. I'm Billy Boshoff. I'm one of the directors of the Concrete Society of Southern Africa. And I will be introducing the speakers, and I will also giving you a quick introduction to the Concrete Society as well. But firstly, you're all very welcome, members and non-members. You're all welcome to this session. We have a session twice a month. We have a session in the beginning of the month about concrete class, which is about fundamentals. I presented last week or earlier this month on concrete mixed design, basics of mixed design. Now we're going to have a more advanced presentation again now with this CONCRETEfix, and the concrete class again on beginning of March will be about concrete durability, which will tie nicely with this presentation, but that will give you more the basics of durability and almost like a university lecture. So I'm just going to start by saying a warm welcome to everybody. You are very welcome. We at the new, we still call it the New Concrete Society, but we are revised now, and we believe in the 6 core values, when we operate: modern, advanced, relevant, streamlined and efficient, objective, inclusive and loyal. That is what we try to do. We've got a number of committees going already. We've got an Inland Branch Committee, a KwaZulu-Natal Branch Committee, a Western Cape Branch Committee. We've got a Ready Mix Concrete Committee, which is chaired by myself. We've got the FIB Committee, that's Structural Concrete. The head of delegation there is Dr. Sarah Scorpin. And then we've got a Cement Branch Committee with the interim chairperson, Mark Hovey, also director of the Concrete Society. Just about membership options. Yes, I have to do marketing because a lot of you are not members. And like I say, you are welcome to attend our events. But this will be the last event where you will be getting CPD points without being a member. You're still open for the public, all our events like these, CONCRETEfix and Concrete Class. But if you want CPD points, you'll have to become a member. And that's not the end of the world, as I always say, because just to become an individual member is 1,500 Rand per year, that all. And then you can become a company member as well, where you nominate individuals to be on behalf of the company and the Concrete Society. You can have different levels from emerging enterprise to a diamond, which is a bit more to pay, but you get a lot of exposure as well. And then you can become academic members as well, and associate members is also possible. Our current members, up to date, as I understand, Natasha, is the diamond members. We have CRISO and Quick Group. We have emerald members, CTS Laboratories and CoreStruck. And Tanzanite members, we've got, I'm not going to read all of them, but there they are on your screen. And there's some more Tanzanite members. Associate members, that's other institutions or other organizations. Academic members, very important for us as well, is these different universities have already joined us. So before I look at the Fulton Awards, I just want to do an invitation is that we do these events every 2 weeks. It's possible because we have a membership base, and our membership base is not as big as we want it yet. We're still building on it. We need a bigger membership base. So if you're getting benefit from these events, please consider to become a member to help increase our membership base so that we can continue with this without trouble in the future. Our big event this year is the Fulton Awards coming up the 7th of June. More information on the Concrete Society website, or if you're a member, you will get an email with more information. CONCRETEfiX, we've got another number of events planned for the rest of the year, but the next one after today is the 20th of March with Dr. Sarah Scorpin and Megan Brink from the University of Pretoria, presenting their work. Then there's another CONCRETEfiX on the 24th of April, but keep watching us for the topic. Back to basics is the concrete class. I said we started last few weeks ago with myself presenting the basics of concrete mix design. And the next topic will be Dr. Hans Boeshausen, which will be quite entertaining as well. I'm sure it'll be about concrete durability, deterioration mechanisms, and basic design rules. Not the kind of advanced stuff we're going to hear today, just the basics. And sometimes we have that basics lacking, so it could be good to attend. And then there's some more coming the 10th of April and the 8th of May. And then we've got a bowls blitz planned for the 13th of March in the Western Cape, the branch. CPD points, I already said there's CPD points that you will be allocated. I think you have to send an email, or Natasha will send out the email with the CPD list, and then you'll get your number, and you'll have a number like you see at the bottom of the screen, and the last 3 digits, the 024, will be your personalized number for exam. So you're welcome to follow us on our website or LinkedIn. We're quite active on LinkedIn. Follow us, and then you'll get up to date of what we're doing. So the success of the society relies on the commitment and support of the individuals, companies, stakeholders from the cement and concrete industry and wider. We thank you for your ongoing support. Thank you for all listening in today. And I'm sure that it won't be a waste of time. I'm looking very forward to this presentation. I'm sure you all as well. So let me not spend too much time on talking about the Concrete Society. Let's get on to the CONCRETEfiX for today. My apologies, the title is not added on this slide, but the title is The Innovative Methods for Lifelong Concrete Protections Against Water Ingress, Rebar, Corrosion, and Mechanical Wear. Now we've got 2 presenters. Fanis Lekkas, just a little bit about his background. He's a naval and mechanical engineer. He is the international sales and marketing manager of CWS, Concrete Waterproofing Systems Limited in Australia, in charge of Europe, Middle East, Asia, and Africa. With more than 30 years of experience in construction and industry export, the team of CWS are manufacturers and worldwide distributors of cutting-edge concrete waterproofing and protection technology. And then Trenton Botha has got over 23 years experience in specialty construction industry. He brings a comprehensive experience in concrete repair, protection, and waterproofing. Having worked in every department from sales to project management to production, research and development, and overall business operations, Trenton has developed a well-rounded perspective that allows him to understand and address the unique challenges that is faced in the industry. Thank you very much for both of you for taking the time to present to us today. We look forward to your presentation, and I will now stop sharing my screen, and then you said you'll arrange amongst yourself who's presenting first or what order you're going to do that. So I'm giving it over to you. Thank you very much.
Thank you, Professor Boshoff. Thank you for introducing me and my friend and colleague Trenton Botha. I'd like to thank the Concrete Society of South Africa for organizing this, and Natasha Pauls for doing all the work and getting us all in the same room or practically in the same session. I'll be happy to be sharing today's presentation. A very big experience on concrete protection and waterproofing and tackling all sorts of difficult and peculiar issues. Trenton, you would like to say hi to somebody, and then meanwhile I share my screen and we can start talking.
Thanks, Fanis. Yes, just want to greet everybody and thank you for all attending this. I think it will be quite informative for you. Fanis, over to you.
Okay, let me share my screen then. I hope you're all, you can see my screen?
Yes.
Yes, we can.
This is great. So let me explain you why this technology that we will be discussing today was developed. When people are mainly talking and discussing about waterproofing and issues and concrete protection, we mainly tend to focus on the dysfunction. I mean, granted, okay, it is not the best thing to have water dripping in a facility, but it's not the fatal thing. We mainly tend to focus on the dysfunction. For example, we might be discussing about a hospital and we have a room full of MRI scanners costing a few $100 million. And of course, it's not fatal. However, it's a very, very big damage if water comes in and damages them. Things become to affect human lives and human well-being if we are talking about a tunnel through which the morning traffic and the evening traffic of a whole big city are passing through, and then for reasons of repairs we have to cut off the traffic through this channel for a couple of months, and then that means that people have to make a detour of 10 to 20 kilometers to go to work and then go back home. This is when it starts to affect communities. However, the really big problem does not come out of this. A really big problem comes out of the corrosion of the rebar, be it because of carbonization in very polluted atmospheres of metropolitan areas, or chlorides and sulfates coming in on seaside or riverside projects. It is actually the corrosion of the rebar that brings buildings down and puts engineers and contractors to prison. And finally, we have the degradation of mechanical wear because of abrasion. Think of car parks, think of industrial warehouses, think of ports and warehouses where containers and cranes are being dragged or dropped or destroying the quality of the surface and damaging, degrading our concrete. You all probably know that there are three major factors that decide whether our concrete structure is going to be resistant to humidity or not. The first and foremost, of course, being the design mix. So what is in that concrete? How much cement and what type of cement did we put in there? What kind of aggregates are we using? Are there aggregates that are coming from a river? In some parts of the world, they cannot afford this. They do not have them. So they are bringing in aggregates from the sea sand, from the seabed, and sometimes they do not even wash them. What other kind of admixtures do we have? Are plasticizers and retarders playing an effect? Are we placing concrete in freezing temperatures, so we have to use extra admixtures and so on? The second is I'd like to say is the moment of truth, the day of presentation of production and placement of the concrete is where most of the mistakes are happening and they decide the fate of the building. For example, in some parts of the world, it's very easy to get stuck in a half a mile or 1 mile distance for about 2 hours. Philippines, Manila, for example. So the mixing truck is leaving the batch plant on the way to the construction site, gets stuck on traffic. The driver of the truck is afraid that the concrete will go stiff on him. He presses a button, he adds some water. If you ask him exactly how much water did you put in there, he says, nah, don't worry about it. I've been doing this for 20 months, for 20 years. I know this inside out. Then he gets late to the construction site. the site manager now, he's worried about workability. He has a little bit more water. None of these gentlemen thought of asking the consultant beforehand. None of these gentlemen had even the courtesy of telling the consultant after they put the water. So if he gets a violent hydration and cracking, he should know where he would start troubleshooting. Then finally, local environmental factors are important. I understand that today it must be a very good day in South Africa, mostly. Here in Greece, we already have 1 degree. In Finland, they have -7. So obviously, pouring concrete in 3 places at the same time, those 3 places, is very, very different. Still, we all know that even after the first 24 hours, our concrete is going to be suffering issues that if we don't plan properly and execute properly, the issues may escalate into problems and then into damage, starting from the very simple and innocent plastic shrinkage or separation of materials, and in the weeks and months to come between winter and summer and the opposite, then we're going to have cracking, we're going to have issues and shrinkage, and then chemical attack is starting to play an issue, carbonization and acid rain starts to play an issue. This is why the building regulations all over the world, and here we are seeing a slide out of the European building code that is in effect as we speak, they have made different provisions about it with classifications of projects where every type of project, be it inland or by the seaside, above ground or below ground, industrial or residential, a water tank or a car park, mostly the things are being regulated, and mainly you are expected to give most kind of information about the project, and then the building regulations will tell you what is the maximum water to cement ratio that you cannot go over, what is the minimum cement that you cannot or should not go under, what should be the minimum coverage in order to protect the concrete. And we are doing all this. Why? Because we want our structure to achieve a maximum service life. So let's say that we are designing a hotel or a hospital and we expect a service life of 50 years. What does that mean? Does that mean that it's acceptable for my building on year 51 to die on me and then we have to throw it away and build another one? Of course not. It means that we anticipate that with design mix and placement processes that we followed up, it will take 50 years for soluble chlorides and sulfates to migrate from the surface through the concrete matrix, get to the rebar, deactivate the passive protection film, and then corrosion will start. Which means that if we are diligent property owners, we should be starting to do preemptive repairs. So if you think that the building regulations will more or less designate what kind of cement or water to cement ratio or even the coverage I should be using for the specific project, the only thing that is left in our hands to protect the longevity of the concrete is by waterproofing it, by not allowing water carrying soluble chlorides and sulfates to penetrate the matrix. So why are we doing all this? To avoid the corrosion. And what do we have in our hands? What are our options? Probably these materials. I'm sure that you have all these materials. You've probably used all of them or most of them during your work career. And I would really like to know on a scale of satisfaction between 1 and 10, I would really love some people to tell me, how satisfied are you? Are you a 1? Are you a 10? Are you a 5? Where are you? Mostly when I speak with people, they tell me between a 4 and a 7. The 7 is really rare. Nobody ever gave me an 8, a 9, or a perfect score of 10. And when I ask why, they tell me all sorts of things. Usually they talk about service life. They say we install them in 1 or 2 or 3 years, they start leaking. And when we go to the nitty-gritty of this, they're not really complaining about the material. They're complaining about the work of this gentleman, top right, that gentleman, and the other gentleman. It is the workmanship that is causing the problems. Most materials, with the exceptions of some really bad ones that I'm sure everybody knows and avoids, all these materials, if they were installed in a controlled environment of a laboratory, they could probably last a very, very long time. But they are not. They are installed out there in the weather elements, under the sun, the scorching sun, the rain, the frost, and the ice, and sooner or later they do fail. So we have to think what we are going to do when they fail, not if, when they fail. And because when they fail, they cause really big problems. For example, this is a shopping mall less than half a mile from our headquarters in Sydney, Australia. They had to close down the mall for 8.5 weeks to make repairs. So imagine how frustrated the shop owners were at losing their income and probably losing their clients altogether, because research shows that when retail customers change the place where they go for their regular shopping, very rarely do they go back. So we need to know how we are going to address the issues that the failure of traditional membranes and waterproofing leaves. Because after the damage they are causing, we still have to repair. For example, you see all these kind of damages that even after the lawyers and the compensations are finished and paid, we still have to pay a lot of money to repair. For example, if we are talking about a dripping rooftop on a 5-star hotel, which has a membrane, then a screed, and then tiles on top, we have to practically start to destroy by trial and error different parts of the rooftop to find the leak, until eventually we have to break the whole thing and do it all from the beginning. Then in 5 or 6 or 7 years, you have to do it again and then again. So as engineers, we say, come on, there must be a way that we have to do it better. Or we are building industrial warehouses and gradually the surface of the concrete, it gets degraded by abrasion from forklifts, trains, cranes, trucks, moving traffic and tool. So we need to say that we should find materials that it would be great if we could install only once and we don't have to pay for it again. For example, this is a spillway on a water dam somewhere in Pakistan, okay, done by a very, very well-known big construction company. And what you're looking here is the spillway area, which became like this 9 months inside the operation of the building. So we say, come on, wouldn't it be great if we could have technology and products that we only install only once and we never ever have to install again, we never have to perform maintenance. And one of these available technologies today, even available in South Africa today, is what we call BMSS, biochemically modified sodium silicates. Usually sodium silicates are connected to concrete hardeners, like, right, something like $1 a liter that you can find around the corner or in every small shop everywhere in Asia. Here we are talking about a biochemically modified technology, which is used not only to arrest the ingress of water, but also to protect the concrete against mechanical abrasion. BMSS is practically liquid CSH. It's practically, you can think of it as liquid concrete within concrete. We apply it on dry and cured concrete surfaces, and then we give it time and it penetrates the concrete. It does not stay on top, it's not a coating, it's not a membrane, and certainly it is not a film. It penetrates about 15-20 millimeters of the top surface, top layer of the surface that we apply it on, and the way that it works is very simple. It reacts with the calcium, which is already in the concrete, and with simple water that we add by watering the applied area on the day of application, on the second day, and on the third day. And it creates an insoluble calcium silicate hydrate gel. You see, it has the same structure as concrete, which is essentially a calcium silicate hydration product. What it does is that it seals the porosity of the capillarity of the concrete on the top. It seals the cracks, it seals static cracks which are already in the concrete, and this is all happening inside the concrete and not on top of the surface. The best of those materials can even seal static cracks up to 2.2 materials, not 0.2, 2.2 material, which is a huge achievement. And then the product will remain active and dormant in the concrete, and in case of a future static crack, upon new entrance of rainwater, for example, it will reactivate again and seal the crack, and that will perpetuate forever. This is a video to show you how instantly the formation of this gel is starting. Here we have a solution of calcium acetate, some water and calcium to simulate the concrete surface. We put a few drops here in that Petri dish. And then we are going to install the BMSS product, which is that demo bottle you are seeing back there. You see that these products are liquid, transparent, pretty much like water. The viscosity is pretty much like water. Now have a look. The first drop goes in. Look. 1, 2, 3. You get an instant reaction. The gel formation starts instantly, and the gel starts to grow 5, 6, 7 times its size. Look, in less than, what was that? 10 seconds, 12. It grew 5, 6 times its size, absorbing all the available water. This material is not a hydrophobic, it's not a water repellent. On the contrary, it is highly hydrophilic material. It loves water. The more you give it, the better it is. However, it's not magic spray. It has some limitations. It's not a nanomaterial. It is practically a liquid concrete material. We apply it on structural concrete with a minimum of 20 MPa, well vibrated and well compacted, no honeycombing, no drummy concrete. We apply it when the surface is dry and cured the full 28 days. Let me explain why. Obviously it has to be dry because, as you saw, this gel formation starts instantly. So if the concrete is damp, is wet, then the gel is going to form outside the concrete without waterproofing it, only staining it badly, and then we have to remove it. Now, we prefer our concrete to be very well cured the full 28 days because during the curing period, the concrete tends to crack. So if it's going to crack, good. Let it crack all at once, because then we are going to apply this biochemically modified sodium silicate, and it is going to take care of all those cracks. After we do the first application, and in the first 1 to 3, 4 hours, our surface becomes touch dry, we water it abundantly for the first time, then the second day and the third day. The application is very easy. We do not need to use some specific, very sophisticated and expensive equipment. Even a normal backpack sprayer, not even motorized, the one with a manual spray, will do. We apply on the concrete, it becomes wet and then disappears, leaves no trace, does not change the texture of concrete. We start watering abundantly. This material is absorbed in the concrete matrix because of the capillary phenomenon. So we do not only apply it on horizontal surfaces, rooftops, balconies, podiums, bridges, and car parks, but also on vertical applications. For example, facades of buildings, water tanks, wastewater treatment, every system where we collect and we distribute water, planter boxes like the one that we are seeing here, rooftop planter boxes, swimming pools, etc. It's really very easy to use, and the short video that you see here is just to show you how easy it is to apply. You just have to make sure you do not leave any untreated areas. Really very easy to use. Now, the incredible thing, the incredibly valuable asset for contractors is the very fast application. You all probably know that if you are going to be installing bituminous membranes, torch membranes, you need one applicator and one assistant to install what? 50, 60, let's say 70 square meters in a day. If we're talking about liquid PU, you probably would not be able to go over 100, 120 square meters per day. This technology, used with a normal backpack sprayer, allows one applicator to waterproof 1,000 square meters in one day. And if he's using a motorized pump, he can easily apply 6,000 square meters in a day. Think about the implications. Think that the contractor can now send out one applicator to do the job of 30 in one fraction of the time that the 30 people would need. Look at this example. Let's say that we're talking about a bridge project, or a marine project, a port, 100,000 square meters. You try to do that the traditional way and protect the concrete, it means you have to stay on that bridge for 4.5 man-years. Or you allow one person to do it all in 3 weeks. Of course, you probably would not send one guy to go there and do it and get back in year 2030. No, You would still 10 or 20 or 30 or 50 people working, but still those people would account for a total of 1,400 man days. Or let's say you have a big rooftop, a medium shopping mall, or a medium shopping holiday resort, 6,000 square meters. Either you put a whole team working for 3.5 months, or you send one person to finish all in 1 week. So the implications and the cost saving is important, as long as, of course, we have properly prepared the surface of the concrete to absorb the material. So anything that blocks the penetration needs to go. We want our surface to be clean, with open pores, free of anything that may block penetration. I don't know, curing compounds, paints, oils, and other contaminants, they have to go. This is a product that also, this technology allows the material, allows the concrete to accept thermal stress up to 160 degrees. Imagine that after you treat concrete with this material, with this technology, you can apply hot asphalt of more than 160 degrees directly on the concrete without first needing to protect it against thermal stress, without a protective layer, topping, or a screed. So think about it. You can apply up to 6,000 square meters in 1 day with one person, and it can even accept hot asphalt. So what is the ideal place to use it? Large areas of exposed concrete. So car parks, rooftops and podiums, bridges, all sorts of marine structures, wharves and ports, shopping center rooftops, green rooftops, landscaped areas, and every kind of system where we collect water, treat it, filter it, clean it, store it, and distribute it to a public. So water tanks, swimming pools, aqueducts are all equally good to use. And as you see down here, I'm stressing that it is ideal for areas which are exposed to mechanical abrasion, like warehouses, ports, and bridges. So all these projects that we see here are great to be treated with this innovative technology. And because I talked even about water tanks, let me tell you that this technology has been certified by multiple international certification boards around the world for use, safe use with drinking water. So why should somebody considering adopting the new technology? Because first of all, it will automatically seal static cracks up to very big widths without other human intervention, without using epoxy resins, injections, and things like this. And then, as long as there is free calcium in the concrete in future, in case the concrete might develop a future static crack, you know, sometimes we have such high temperatures around our world nowadays that concrete that is even 5 or 6 and 7 years old have been known to present shrinkage cracks, okay, because of expansion and contraction under the very high thermal stresses. So if there is free calcium in future, then this technology will even seal a future static crack. Now, in case that we really want our project to enjoy future crack sealing, we generally try to avoid pozzolanic materials like silica fume, microsilica, or fly ash to high percentages, because they tend to block the free calcium. So we can limit these pozzolanic materials to around 8%, because generally we use them to make the concrete more dense and waterproof, right? So we don't have to use so much. We can take them away altogether, or if the consultant definitely wants to use it, it's okay to use up to 8% of these materials without any issue affecting the future crack sealing. Furthermore, after this CSH gel is formed under the surface of the concrete in those 15-20 millimeters, it stays there forever. It does not leach out to the horizon like calcium on carbonized concrete. Actually, even if you change your mind, you cannot take it out. It's just trying to take out sugar out of a cake. After the cake is out the oven, it's impossible to take the sugar out anymore. On the contrary, the gel will stay there, protecting the structure from water and soluble chlorides and sulfates for the life of the structure. I've already talked about withstanding thermal stress, and the crack the crack sealing ability, the static crack sealing ability of this technology can even reach up to 2.2 millimeters. Well, naturally, not all products will do that, but they will seal static cracks, okay? Sealing the porosity of the concrete completely means that we are essentially protecting the steel rebar against corrosion. That means that you can even take away the corrosion inhibitor out of the design mix. Some consultants say, is this a corrosion inhibitor? And we say, no, it's not a corrosion inhibitor. The corrosion inhibitor is just an admixture that will wrap around the steel rebar, protecting it passively against chlorides. Here the technology is different. It is the porosity of the concrete which is completely shut off to the entrance of chlorides and sulfates, which means that you do not need to use it. Then they have the opposite question. Okay, I understand. Still, if I want to use a corrosion inhibitor, can I use it in conjunction with this BMSS technology? And we say, of course, be our guest, no problem. Very importantly, this technology will accept unlimited hydrostatic pressure from the positive side, the side we apply it on. When people say, what do you mean unlimited? Well, actually, the answer is that as long as the concrete is not collapsing under the pressure of water, then the BMSS technology will stay there, protecting the concrete against water ingress. Then again, this technology has a peculiar effect on the pull-off strength of concrete. It increases the pull-off strength of concrete between 27 and 81%. That means that if you are using subsequent layers of materials, tiles or marble plates or what have you, by using a cementitious glue, that means that the bond of these subsequent layers on the concrete surface is now going to be between 27 and 80% stronger than before, which means longevity on coatings of buildings, for example, on facades of buildings. In several parts of the world, we tend to cover the facades of buildings with tiles or big marble plates. And so this is one more reason why somebody should think of adopting this technology. Now, thinking construction and what that would imply for construction, think of this. Most of you that may be dissatisfied from the traditional materials that we were talking about earlier, we have been attributing this to human error, to workmanship, right? And of course, if you're going to do, for example, PU membranes, you have to very precisely mix specific proportions of materials, and then you have applied 3 coats, one on top of each other, less than 2 hours apart at specific layers, and of course human error is sooner or later bound to happen. Here, as you see, we're talking about a very simple application, a simple spray application on the concrete. We give it time, it goes in, surface becomes touch dry, we water 3 times, very simple to use. Good technology should be simple. Good technology should be problem-free technology. And this is what we're talking about. We install once, we never ever have to apply again in future. The project owner can eliminate the waterproofing cost out of the future cost of use of the building, which at the end of the day makes it much more economical than any kind of traditional waterproofing. Then again, talking about the contractor, you know, we rarely think about it. The contractor got the job. Why? Because he gave the rock bottom price. And then he needs to find ways not to waste more money and to make some profit out of the rock bottom price that he gave. So let's think in contractor terms. Usually, you may know, I hope, that most of the traditional waterproofing membranes, bituminous, torch, PU, whatever, they get destroyed either during the application or on the last day that the crew are packing up. So they're finished, the foreman says, okay guys, we're done, pack it up, let's go home. So they start picking all the tools and all the extra materials and the remaining. Somebody accidentally drops a hammer, or he's dragging a 2 kilos aluminum ladder. However, he's nicking the membrane just a little bit, not enough for our eye to see it, but the scratch is there. Then we cover with the screed, the first rains come in and it starts leaking. this material cannot be damaged by subsequent work because there is nothing left on the concrete surface to destroy. We send one applicator to do the job of 30 applicators in one fraction of the time. And of course, if you can go up to 6,000 square meters per day with one applicator, it means that obviously the deadline that you are given is very easy not to miss it. You need much less time than the traditional time you will be given, which means that the contractor does not have to worry about paying liquidated damage claims, delay compensation to the contractor, or the contractor to the project owner. And of course, going to the owner and telling him that you finished that project 1.5 months earlier than he anticipated, I guess would only make him happy, right? That's a little bit more about technical stuff. This technology being underneath the surface of the concrete means it does not change the friction coefficient of the surface, which means it does not become more slippery as happens with some normal concrete sealers and hardeners. And this is not only safety in car parks, as I'm saying here, but also safety in areas of pedestrians, where people, like children, are playing or running, or ramps for people of disabilities. I've already discussed the protection against chemical attack from chlorides and sulfates. And you know, generally people think that seaside projects are really risky, while riverside projects are generally more safe. But you never know what kind of contaminants are coming down from industrial waste from factories which are upstream, right? Finally, and very importantly, this technology, when applied on concrete and properly watered in for 3 days, then 7 to 10 days later, the formation of this gel has concluded. And as a result, the surface has increased its concrete hardness up to grade 9 of the Mohs scale. Think about it. Granite has a concrete hardness between 6 and 7, 5.8 to 7, depending on the geography that we mined it out of. So that means that now we have increased the concrete hardness to much higher level than granite, and this in plain English means that we do not need to use a protective screed to protect the waterproofing. Normally, on top of an area that we have protected against moisture with a bituminous membrane or a torch membrane or PU, we have to install a screed to protect it, right? Or cementitious. Here, you don't need to do that. You fully eliminate this part, this phase of the construction, which means you save the money, you save the material, you save the time, everybody wins. For example, this is a podium in a high-rise building somewhere in Indonesia, in Surabaya. After this area was done with CWS 100, they brought in the materials that they were going to hoist up on higher floors to continue the construction. Would you ever allow anybody to do that on top of your membranes, no matter what kind of membrane you have, even polyurea, which is really expensive? You would be crazy, actually, because that would be damaged. But here, there is nothing left on the concrete surface to damage because this technology is working below your concrete. Actually, after the first watering has been done on the first day, the area is fully trafficable. So if I'm talking, for example, let's say we have a car park. If you want to re-waterproof a car park with the traditional means, the first thing you have to do is close the car park from business for the next, I don't know, 2 weeks to 2 months, right? Here, you don't have to do that. You just segregate, let's say, 500 square meters of the car park while the rest is in operation. You apply the product, you give it time to penetrate, you water it. You open the area for business. You move to the next 500 and then the next 500, so we can re-waterproof and re-protect projects while the projects are still in operation, generating income for their owner. This is a pleasant side effect of this technology. This gentleman here is washing off 2 years old graffiti from the walls of a museum in Brazil. Anybody that knows graffiti can tell you that even after 2 days, you have to grind it off to take it out, okay? But here, because the porosity of the concrete is so completely sealed, not even these very fine particles of graffiti can penetrate. Granted, there are normal graffiti, anti-graffiti films, but you know, in a place where they tend to smear very often, for example, it could be a wall of a building, it could be a stadium where the people of the teams, they go and they smear with graffiti. You have to clean it off and brush it off every other week. So after you do that for 2 or 3 months, you have to apply the anti-graffiti membrane again. Here, you never ever have to do it again. Finally, let's talk about the protection of environment, because South Africa is one of the most advanced countries in construction. Let me tell you, it's one of the greenest materials that you can find in building today. Completely atoxic, zero toxicity, zero carcinogenic materials, zero volatile organic compounds, and as we said before, absolutely safe for use with drinking water. And then again, think in contrast what we do with membranes. When the time comes where the membrane is going to fail, we take away the membrane, and then what? We cannot throw it in the garbage of the house, right? Because they are toxic. We have to put them on a truck, drive far away on designated landfill, and dump them there. But here you don't have to dump anything. On the contrary, when the time comes to bring the building down, this concrete is fully recyclable, okay? Whereas the membrane are really not friendly for the environment. Let me share with you, because talk is good and talk is easy, but let me share with you a video to show you in action. This area that you see here is the rooftop of this hotel, Dialogue Hotel in Bali. This is 2,380 square meters. Now look, the camera will go down. As you see from below, it is completely dry. No other application of other technology, just the BMSS, biochemically modified sodium silicate. Impressive or not? And you know what? The real impressive thing, it's not that it's not dripping, because this is what this technology is about. The impressive thing is that those 2,380 square meters were done by one applicator with one spray and 3 waterings in 4 calendar days. How many people would you have to use with your team to finish it, and how much time should they be using? Now, you know, I may mislead you and give you the impression that this is magic spray. So obviously you cannot go up to Sandon skyscraper with a couple of bottles. You spray BMSS in the air, the whole South Africa becomes waterproof. No, by no means. But if you compare this technology with traditional membranes, this is light years ahead. All this kind of traditional waterproofing has a limited lifespan. Sooner or later it will fail. Here we're talking about lifetime problem-free waterproofing. We don't have to apply in future. It cannot be torn, it cannot be scratched. You don't have to worry about UV radiation. You don't have to worry about root penetration. You don't have to consider and worry about the number of the coatings, the thickness of the coatings, the adhesion of the coatings. You don't have to worry about safety for use in drinking water in swimming pools for children and families, or drinking water. It will seal static cracks, current and future, and does not require screed, and generally stays there forever. So I really don't know what is not to love and embrace about this technology. I know that change is difficult, but I would like to ask Trenton to tell you what his experience had been, because Trenton has used this technology both in residential areas, in supermarkets, in car parks, and even bridges where they will be installing hot asphalt. So first of all, if there are any questions, we will be happy to answer them. Let me stop sharing here so we can see each other, and we'll be happy to receive your questions.
Thank you, Fanis. I see, Jacob, you've got your hand up there.
Yeah, thank you very much for your presentation. I hope you can hear me. Can you hear me?
Yes, we can hear you.
Yep.
Yeah, thank you so much for the presentation. Yeah, I see that the material is good for when you have a static crack. Yeah, and we know that concrete, there is no way you will have, concrete is not all that impervious, and at times you have some micro cracks inside the concrete. Now, how do we ascertain that the micro cracks inside the concrete is static for effectiveness of the use of the material? Because in most of the structures that we have, the cracks grows as time goes on. If you now apply the material and you discover that the cracks are moving, now, how do we now ascertain the effectiveness of the material in sealing those cracks that are growing? Okay, or can we say, okay, how do we ensure that there's no growing cracks inside our concrete for the effectiveness of the material? Thank you.
Thanks, Jacob. I think if I can answer that one, you would have to determine should that concrete crack in the future, if that crack is active or static. If it's an active crack and it's moving and opening and closing, you would have to dress it in a different manner and use maybe a flexible polyurethane injection technology or a bandage over the crack, etc. So there are solutions for that. So like Fanis said in his presentation, the product is a great product. The technology is fantastic, but it will seal static cracks. Should that further hairline cracks appear, it will automatically seal those. I think if that answers your question.
Yeah, you've answered my question. Yeah, but I think is it possible to apply the product in such a way that maybe there's another product you have to apply to see the cracks before you apply the product, so that you will ensure 100%, effectiveness of the material. Okay.
Yes. I understand what you're saying. So typically the applicator would do a thorough inspection of the deck before, or of the concrete structure before any application is done, so that any repairs that may be necessary, such as honeycombing, active cracks, etc., are addressed properly before the waterproofing is applied onto the concrete.
Okay, thank you.
Yes, Billy?
I've just got a question about the environmental friendliness. That's confusing me a bit. You say it's very environmentally friendly for all of those reasons you listed, but you require the concrete to be a 92% OPC, 92% clinker, where you could have gotten away with a 50% clinker or something mix. Aren't you doubling almost the emissions, the carbon emissions from embodied carbon from the concrete by applying this product?
Fanis?
Yeah, if I may answer this. Listen, the reason that we are advising to use less pozzolanic materials is not because the product, the technology is not going to work. Whatever you apply it on a new construction, even with much higher percentages of fly ash, it will seal and stay waterproof forever. It is only if we would like our project to enjoy automatic future crack sealing that we would advise to limit the pozzolanic materials to around 8%. Well, if you're using, for example, fly ash of type F. Now, some consultants, they said, yep, I have no problem for it, but others, for reasons that you very well explained, they say, no, we want to use a higher percentage of fly ash. In which case, of course, there is an alternative. Instead of using type F fly ash, to use type C, because type C fly ash is super rich in calcium, and percentages of fly ash type C up to 30% can operate and coexist with this technology, ensuring the future crack sealing. On the other hand, somebody might consider substituting fly ash with slag GGBS, in which case it would play no effect how much of it you put in the construction, as it is super rich in calcium, and the future crack sealing ability would be ensured, the automatic future crack sealing ability. Now, having said that, of course, if you would like to go ahead with type C of 20, 25, 30%, you are free to use it, just in case the concrete, it might develop a future static crack, as difficult as that be, because concrete does not wake up one day 5 years later to develop a static crack, right? There must be some dynamic phenomena that caused it. But even in that case, in case that in the locality of the new static crack, if there is not enough free calcium for the product to react with and seal the crack, remedy is very easy. We just apply a 3% solution of calcium acetate, to restore the missing calcium. We spray a little bit of this technology inside, water 3 times, and the crack will seal again. So we can sustain the effort that everybody is doing to reduce the carbon footprint by a simple manual remedy.
Thank you
Grant?
very much.
Grant, how are you?
Yeah, good. Thanks, Trenton.
Excellent.
Thanks, guys. Just a quick question in terms of the alkali content. Is it high? And if it is high, is there any risk associated with ASR with certain aggregates?
Look, the product is has alkalic nature. This is true. It can withstand acidic environments with a pH, well, general environments acidic or alkalic, between 3.5 and 14 without any problem. Okay, having said that, it does not, it will not protect against ASR. So if your aggregates are going to promote ASR, CWS 100 is definitely going to help by not allowing water to penetrate. However, if there is already moisture inside the concrete and you have aggregates that are coming from areas that may promote ASR, it is not the job of CWS 100 to stop this reaction. It will protect against ASR, which will be triggered by moisture coming inside the concrete later on after the pouring.
Thank you.
Anybody else got any questions? From my experience applying these products in Africa and Southern Africa, the speed of application is just absolutely phenomenal. Track record on 4,000 squares of bridges that were done within a week to enable the contractor to put their asphalt on top of it. This particular system was a failed membrane that had to be taken off completely, bitumen removed included, and then the product applied on top very successfully. We've got very successful local tests on this technology too. Open to any other questions? Yeah, I'll take Richard first.
Is the application compatible with the other silicate solutions like Zypex and those ones?
Is it compatible in what terms? To use a belt and braces system with the two products?
Yes, I suppose that could be the question. Is there any adverse reaction between the two types of products?
Not at all. We have used it successfully with crystalline in the concrete admix, as well as this product applied on top of the surface. They work very nicely as a belt and braces system.
Okay, thanks.
Yeah, next question there.
Hi, Trenton. I might have missed it, but I just wanted to know, so if you have large concrete areas and it has been cured with curing compounds, will your product still be compatible, or is it only to uncured or water cured concrete?
So ideally water cured or sand cured concrete would be great. If there is a curing compound applied onto the surface, be it acrylic resin, etc., there is just preparation that takes place before. So either high pressure cleaning or grind the curing compound off.
If I may add to this, there are some curing compounds which are biodegradable by themselves. Okay, so around day 24, 25, you just power wash them and they go away. So these ones you just wash and you're good to go. The other ones like acrylics and resins and emulsion rubbers and things like this, exactly as Trenton said, you'd have to remove them mechanically.
Trenton, sorry
Yes,
for the
Billy.
question, but are you still planning to give a presentation or?
No. I was just here for technical questions. So.
Oh, I misunderstood that from the start. Sorry,
No
it was my
problem
mistake.
at all.
Oh, so we can continue with questions. Otherwise, we would have had to get a move on to get to your presentation.
No, open the floor for questions.
Okay.
Sorry, I have another one, if I may. I think our
Yes.
time is up, but I also remember, so if you have applied this product, what subsequent products can you put over it?
You can put absolutely anything over it. And epoxies bond very well, so it increases the bond, the pull-off strength of the concrete. So any additional material applied on top actually improves the bond of that material onto the system.
If I may, there is nothing left on the concrete surface that is blocking you for doing what you do on normal concrete. The product, the gel which is formed, has the same structure, the same nature as concrete, so it's not a foreign object. Couple of things that you might think you might have need to have in mind is, if you are going to be using some epoxy flooring, you should use some epoxy primer. If we're talking about a car park where we have these yellow lines, the traffic lines, it would be a good advice not to use a water-based paint, because this technology being highly hydrophilic, you should be sure that sooner or later it will absorb the water out of the solution of the paint, and the paint may start peeling off after, I don't know, 2 to 3 months. So you only have to remember to make sure that the paint is not water-based. Apart from that, you can do anything you want on your concrete. It's plain concrete.
Alright, I've got another question. What is the age of the oldest structure with this product on?
138 years. Should be very old, I guess.
Okay.
That was Logan Heritage Building. That was an English Victorian building in Malaysia. And that was treated, that was done with CWS 100. The only thing that they needed to do, because at that time they didn't have fly ash or pozzolanic materials, so we didn't have to worry that free calcium may have been blocked. The only thing they did is they power washed it. They made sure everything was level. They took away whatever might have been on it. They applied water 3 times. They were done in a week. 138 years old.
Fanis, I think what Billy meant there is, what's the oldest track record in terms of a building where this has been applied on previously?
Sorry.
Not an old building.
All right, forgive me.
Yeah.
Forgive me. This is a technology that is already 25 years old now. And the oldest building that was done with it is already 25 years. More questions?
I think that's it.
All right, I think I will. There's one more question from Quibus.
Yes, Quibus.
Sorry, I typed in the chat. I just want to know, how does the system react to fire rating? Sort of, if your building burns, does it have a negative effect or anything like that?
I think because it has the same matrix as the concrete, it'll have no effect whatsoever.
So it has never been tested for fire rating or anything like that, or that you know of?
Forgive me, because I don't have very good sound. Are you talking about fire resistance?
Yeah, fire
Fire
resistance,
rating.
yeah.
Okay, look, as you probably know, if your building catches fire, the least of your worries is your waterproofing. After 300 degrees, the concrete is already destroyed. Having said that, however, we have been doing tests by using hot asphalt directly on the concrete and then heating it up to 305 degrees without degradation of the concrete surface.
Okay.
305 degrees Celsius, right?
I just want to add to that, the general rule is the more denser the concrete, the worse it performs in fire. So we should just think nicely about densifying the concrete. 300 degrees Celsius is not very hot. It can go up to 400-500. So, but never mind. That was just my comments. Any other final questions?
I see Martinez posted one in the chat that says, would it not be better to use higher strength concrete? You will naturally have higher calcium hydroxide, promoting autogenous healing. Well, naturally you'd want to use higher strength concrete because it's high in the calcium.
Look, in several parts of the world, people are using very high density concrete. For example, in the Nordics, in Scandinavia, it's very easy to see C50, C60, C65, C70, okay? So would that concrete be absolutely waterproof without needing this technology? Yes, definitely. However, what happens if or when this concrete cracks? Because nobody can stop concrete from cracking. So in case the concrete cracks, then the concrete is open, is just a sitting duct for water carrying soluble chlorides and sulfates. It is exactly in cases like this where this material, this biochemically modified sodium silicate, would wake up, seal the crack, and save the integrity of the concrete, and of course the steel rebar against corrosion.
All right, I think we're going to take one more question, then I'm going to end the session. I see already a few people are leaving. So Jacob, you've got a question.
Yeah, thank you. My last question is this: the material, can we use it for paste or for mortar? Is it working with mortar and paste? Because we'll be talking about concrete. So can we apply it for plaster service?
Look, technically you can, because mortars and renders are rich in calcium. However, mortars and renders are also famous for easily peeling off and dropping off. So if they do and when they do, there goes your waterproofing. Technically, yes.
Okay.
Thank you. Thank you very much. I want to thank again Fanis, Lekkas, and Trenton, Botha. Thank you very much for taking the time, preparing the presentation, getting ready, and getting all suit and tied. Thanks, Fanis, for that.
Thank you, Professor. Thank you. Most kind of you.
So I want to thank you all. This video will be, with the permission, we'll just make sure I wasn't in that discussion, but I think it should be going on YouTube, on our YouTube channel. And if you also just keep an eye on the YouTube channel, and also keep an eye on your email for the CPD points for this session. So for me, from the Concrete Society side, thank you very much, and I hope you have a wonderful evening, and I see you at the Back to Basics. If you're interested in concrete durability, the basics of concrete durability, you're welcome to attend us there. I don't have the date, but somewhere in March, early March. So thank you very much, and goodbye.
Thank you, Billy. Thank you, Fanis. Thanks, Natasha.
Thank you, everybody.
Thank you.
Keep well, everybody.
Thanks, Billy. Bye. Enjoy your afternoon. Bye. Thank you.
Thank you.